Let us look at proposition number 2 of book 7 of Euclid's Elements. The proposition says to find the greatest common measure of two given numbers, not relatively prime. Now here, there are basically two situations. One where CD directly measures AB, and the other case is when CD does not measure AB. So let's see these cases one by one. Given that AB and CD are not relatively prime, the first case is CD measures AB, and actually CD will also measure itself. So CD is a common measure. And any number greater than CD does not measure CD. So which means CD is the greatest common measure. So this was pretty straightforward, this part. Now let's see a situation where CD does not measure AB. We apply the Euclidean algorithm. So which means we take CD and repeatedly subtract it from AB. So when we repeatedly subtract it, we end up with B being subtracted from AB. And A becomes the remainder less than CD. Now we use AE to repeatedly subtract it from CD. So CF is the remainder. Let's continue with the proof now. CF is the remainder when Euclidean algorithm is applied. So ultimately CF is the remainder. Remember, this cannot be 1, because if it is 1, if CF is 1, then these two numbers AB and CD will become relatively prime, and we are given that they are not relatively prime. Okay, so assuming CF not equal to 1, we know CD measures AB with remainder AE less than CD. We know AE measures CD with the remainder CF less than AE. CF measures CD since CF measures AE and AE in turn measures FD. So we can say CF measures CD. CF measures BE. How? Since CF measures CD and CD in turn measures BE. CF measures AB since CF measures BE and CF measures AE as well. So we can say CF measures AB. So which means, see here, we have already shown that CF measures CD, and now we are showing CF measures AB. That means CF measures both AB and CD. We have arrived at the common measure. But now we have to show that it is the greatest common measure. So for this, we will use contradiction. So CF, let's assume, is not the greatest common measure, which means there must be some number which is greater than CF, which is the GSM of AB and CD. So keeping that in mind, we see that G measures BE. So let me bring in G as well. G measures BE since G measures CD and CD measures B. G measures AB and BE. So G measures AE as well. G measures FD since AE measures FD and G measures AE. G measures CF since G measures FD and G measures CD. This is where the contradiction arises. G cannot measure CF since G is greater than CF. Since we have reached a contradiction, our assumption was wrong, and we can say that CF is the greatest common measure. So that was proposition number 2 of book 7. This first case, I gave you an example of 2 and 4. An example for this where CD does not measure AB would be 6 and 16. 6 doesn't measure 16, and their greatest common measure would be 2. Please go through these steps carefully and try to understand. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.